Hi, welcome to the Intro Stats lecture series. And we are in the unit Testing Hypothesis. This is our lecture number 7. And this is the second video for the lecture number 7. And we are doing the hypothesis testing on the population means here. All right, so from the previous video, we talked about we have 2 ways to test the hypothesis for the population means, right? So one is we talk about use z-test, and other one is use the t-test. So the previous video, we finished one, how do we use the z-test? So this video, we're going to talk about how to use the t-test to find the testing the hypothesis for the population mean. Okay, so now let's go back to our lecture note here. Okay, so let's start, for the population, and okay, so for the p-values, we talked about the last time, we said the p-value, you can use the TI-84 calculators, right? So for the TI-84 calculator, we said, if you still remember, we go to what? We go to the stats, right? We go to the stat functions. Now under the stat functions, we go to where? So we go to the test, right? So under the stat functions, we go to the test. Let me see here. Yeah, so we go to the test here. Now, under the test, what do we do here? We say we do what? Z-test, right? Okay, we do the z-test. And also, let's kind of refresh our memories here. So the z-test is what? We say you use your sample average minus the mu0, minus the mean you want to test. And also we say here, we say that divided by the sigma of the square root of n. And also when we said, for the z-test, one big underlying assumption is what? That means the population sigma is what? Is known, right? Or is given. So that's why we say, okay, if the problem they give you the sigmas here, is the population sigma, if it's known, then we can use z-test. Okay, so how do we use R? So the TI-84, we know how to use R. So the R code here is also pretty, the good here. So because of our server, we have the certain type of the function loaded into our server. So this is how do we find use the R code to find our p-values here. Okay, so we use the note here. Change the color so we know. Okay, so the node here will be XP, okay, NORM. Or is lowercase here, okay? And now inside here, you put the values of the things you want to test. So for examples here, we did the example for the first example, right? The college students, they try to use we try to see the number of the cup they use, right, from the previous video. Okay, so we said, so in here you say it's 476 minus 500, right? You kind of like you find then you divide by the sigma. Sigma is 42 cups, so you said 42. And then you divide by what? The square roots, so you put SQRT. Okay, so you said SQRT square root of the sample size is 50 here. Okay, so the square root of the sample size is 50, and then you put the mean here, because this is really your z-score, right? So you put the mean is equal to 1 to 0, because now you change it to the standardized normal, and then you put the SD is equal to 1. And then in this ones here, it will give you the p-values here. So in here, one thing here, we need to be very careful here, okay? So the p-value, so this will give you the p-value. So the tail value, it will be the what? Will be the p-values, right? Will be the p-value, okay? If it's one side, okay? So if this is for the one side test, okay? So if you have a two sides test, so what is your p-value? So it's 2 times the tail value here, then will be what? That will be your p values here. Okay, so that's we need to be careful here. Okay, so that's one thing here we need to be very, very careful about the one side or, you know, two sides here, right? So will be the p-values here. So make sure here that will be two times the tail value will be the p-value, and this is for the two side what? For the two side test here. Okay, so make sure you know how to do that. And now what we can do is we can go ahead and take a look. Let's go to the R, and let's take a look. How do we do that? Okay, so now let's see here. Okay, so here is the one oops. Okay, so here this is the one I wrote it here. Hold on. Okay, so here this is oops here. Okay, so copy. Okay, so you copy here. Okay, so you use the XP normals, right? So this is a 476. Right, so this is a 476 minus 542 by the square root of 50, mean is equal to 0 standard deviation. So this is your z-score, right? So basically this is your z-score. Okay, so if you run these programs here, let's see here. So if you run this program and take a look here, right? So if you run these programs here, and you will see the values here. Okay, so it's 2.66. See that? So that will be your p-value is 2.6656 to e to the negative 0.5. I see here it's very, very small, right? So, but you know, for the example number 1, our hypothesis testing is, are they different? So it's a two-side, right? So it's a two-side test. So what do we need to do here? So the p-values for that will be equal to what? Is 2 times 2.6656 to the e to the negative 0.5. Right, so for this number we know before. So what is this one here? So 1, 2, 3, 4, then 26656, right? So it's a 1, 2, 3, 4, 5. Then because this is two side, we need to times 2 here. All right. Okay, so this is a pretty easy way to do by using the R. Of course, like I mentioned before, if you have you know if you have the TI calculator, maybe the calculator is easier to do. So here, be careful. This will be the lower case here. Okay. So this is SQRT. So it's a square roots here. Okay. Okay. Now let's take a look. We finished. So I think we'll cover all the z-test. Okay, the t distributions here. So if you can still remember, what is the t distribution here? The t distributions is when the what is when the sigma is what when the population sigma is what? Is unknown. Correct? So it's not given. So if we don't know what is the population sigma, then we calculate, we call this the simple standard deviation by using the data, right? The simple standard deviation. So what is the simple standard deviation? It's S here, right? So we said the T distribution, the way we defined is what here is the X bar minus mu 0. So mu 0 is what you want to test for, right? And then the bottom, the only thing different with Z test is you put a what? You put a, you put the S, right, instead the sigmas here. So you will ask, what is the, how is the T distribution versus the normal distribution looks like here? Okay, so in fact, the T distribution and the normal distribution are very similar here, right? So they both kind of like they both kind of like the bear shape here, right? Bear, so let's see here. So let's say here, if this is my normal distribution, it's a bear-shaped normal distributions, right? So what is the T distribution? So let's say here, this is my normal distribution. Okay, so it's symmetric and kind of bear-shaped. Now, what is the T distributions here? T distribution is a similar shape here. So like in here also, it's like that, okay? So this is a T distributions here. So compared to the normal distribution, it's very similar. Correct? So the T distribution is very similar. The only differences here is the T distribution, it has a little heavier tail than the normal distribution. Okay, so it has a little bit of, see here, the tails, the areas here, right? So the tail is a little heavier than the normal distribution. And, but then when the sample size, like we said, when the sample size increase, then what happens here? Then the T distribution will be very, very close to normal, all right? So that's, you see here also, right? So like if the sample size is large, typical, we say large, 40 or 50, and then the T distribution and the normal distribution almost will become, the same distribution. The reason why we want to talk about the T distribution is because, like a T distribution, we say is when the population sigma or the population standard deviation is unknown. And this is a very common problem because most of the time we don't know what is the population standard deviation. So with the population standard deviation is unknown, then how do I test the population mean here? So this is what the T distribution was invented for. It's specifically, is when the population sigma is unknown, and also it's good for the smaller sample size here. So the T distribution was developed by the statistician named Gasset. And the reason why we call this a student, T distribution, or some, the people call that we call this the student T. Right, so we call this the student T. The reason why we call this a student T is because the people said when the Gazette first tried to publish this paper and publish this T distribution, he was very humble. He was thinking, I'm still in the learning mode. So that's why I try to be very humble. So he used the name as a student to publish this paper. So that's why, when you talk about T distributions, and then typical we talk about is student T also, all right? So they are the same thing. Okay, so for the data, in order to have a T distribution, we do have some assumptions here. Okay, so the first one we call it the independence assumptions, okay? So for the independence assumption in there, so in fact, we do have like 3 little things about the independence. So that means the observation. So whatever you're the samples, right? So observation, they must be independent to each other. Right? So when I take the observation, so they don't have any relation, they must be independently. Then the next thing here is that when you take the sample, you have to be random. Okay, that means when you take the sample, this sample has been randomizations here. Then the other things here, in order for the T distribution to work, we say we need to have this 10% rule of the population. What's that mean? What this mean? That means, for example, if I want to find the average income for this city. So if this city, I have, let's say it's a very small city, I have 1,000 families. So when I take the sample here, all right, so my sample has to be less than 10% of the population in order to be the satisfied assumption of the T distribution. So with this 1,000 families in this city, for example, this is my population. If I'm taking 200 families to try to check for the average income, then that's not match the 10% population criteria. Okay. Then the next thing is here, we said the normal population assumption. So in here, so the assumption, theoretically, when the T distribution was derived, we said the sample, we sampled well from, okay, so it's well from a normal population. Okay, but we really sometimes we don't know, right? So it's very hard. It is very hard to be sure the sample you take, the sample taken was from a true normal population. Okay, it was very difficult to, to make sure for that, because of course you can do some testings, right? But even testing, sometimes we're not 100% sure this is what it is. So kind of violate when the T distribution was derived, the periodically was derived, how do you find the population is normal? So we say, well, it's very difficult, but if we really cannot show it's a normal population, as long as you are close enough, it's good. So that's why we say it's a nearly normal condition. We say, well, that's good. As long as it's close enough, I'm fine. All right. So what is the nearly normal? That means when you take samples here, right? When you take a sample, as long as they are looking at, as long as they are kind of the normal looking, then that's be fine. And but then in here, we need one thing here we need to be careful is like for the smaller the sample you take, and then you need to be more close to the normal distributions here. Okay, so let me see here. Let's okay. So let me put it in here. So I just okay. So it tells you here, the smaller the sample, then this distribution has to be more closely to the normal models here. So when we talk about a small sample, that means if your distribution is less than 15, so the way you can do it, you can do like the histogram and to see is how how much it look like the normal distribution. Then if your sample size is moderate, right? So if your sample size is moderate, it's, let's say between 15 and 40, then the T will work very well as long as the data, if you plot it, is unimodal and reasonably symmetric, okay? It doesn't have to be perfect, okay, to be, the T distributions here. Then the last things here, they said, if it's a large sample, 40 or 50, then the T methods here will be safe to use for the data. It doesn't really if you have like the normal distribution or not, we preferred, but with larger sample, that's okay. Okay, so now let's take a look. How do we use the T distribution? I also like to do this part by using the T table, TI-84 calculator, or R. And I like to use this example to show how do we do it. Okay, so now this one's here. Let's try to highlight the things we learned here. So indicate the bottles of the wine, should have a volume is 0.7 liters. Then a sample of 6 bottles from the wine importer give a mean 0.697 and give a standard deviation is 0.01. So I want to see, do you have enough evidence? And then this wine importer is underfilling the bottle here. Okay, so just like we did before, let's try to write the downs, right? So what do we try to test? So my null hypothesis here is the average is what? The average has to be what? 0.7 liters, right? Correct? And so this 0.7, this is really what is the value I called? This is my mu zeros here, right? So this is my mu zero. And now I want to see if this wine importer is underfilled. So what I'm testing? I'm testing mu is less than less than 0.7, right? So this is a one-side test, right? So this is just, so that means in here, this is my T distribution. So this is one set test here. Okay, so now let's try to find the test statistics here. So let's try to highlight all the values here. The sample of 6, so n is equal to what? N is equal to 6. And let's say from this sample, I have a mean is 0.697. So what does that mean? That means here your X bar is 0.69 what? 697. And a standard deviation is 0.01. So this standard deviation is from this 6 bottle, right? So what is this 0.01 is? This 0.01 is a standard deviation, so it's a S. So it's a 0.01. Okay, and then now, based on the formula from the first video we saw here, this is X bar minus mu 0. And what is here? This is what? This is S over square roots of the n's here, right? So we can just put all this value in here. So what is X bar here? So this X bar is 0.697 minus 0.7. And then here, this is a 0.01. So that is the S, right? And divided by the square roots of what? Divided by the square roots of the 6 here, okay? So now let's take a look. How do I get this from the TI-84 calculator? Okay, so let's stop sharing. Let me go to my calculator here. Okay, so here's my calculator here, all right? Okay, so now Okay, so let's clear that. So what are we doing? We're doing the stat, right? So make sure you write it down, stat. Then what are we going here? We do test. All right, so now what is this test? It's a t-test. All right, so you go to t-test, you say enter. So you use the statistics. So mu0, okay, so let's, it's a 0.7, right? Then your x bar is a point, okay, let me clear this one. So the x bar is a 0.697. And your province here, they said the standard deviation is what? It's a 0.01. Then you have, point 0.01, right? And you have 6 samples, right? So you want to test, it's on the field, so it's less than mu0. Then you do calculator, and whoa, what do you have here? So you got is a negative 0.734, okay? And your p-values here is what? Your p-values here is 0.2477 here, okay? So see here, right? So in here you see here, right? So they tell you you are testing is under field. So this is your test statistics, and this is your p-value. Just like we did for the proportion test, it's the same things here. So let's go back to our worksheets here. Okay, so now what is the, we just got it from the calculator. So what is the, I think this is a pointer, negative pointer 734. I think it's negative 734A, right? It's negative 734A, and also the p-value here from the calculator, it will give you what? The calculators here is a 0.2477, right? So this is a 0.2477, right? So this is what we use the TI calculator get you here, right? So the TI calculator, okay, so how do we do that for the TI calculator here? Let's write this one down so you'll be able to refresh your memory here. So for the TI calculator, we do what? We do stat. After stat, you do what? You do test. Now, which test do we choose here? We choose a t-test here. All right. Okay, so now let's stop here, and then our next video, we're going to continue with the t distribution, and let's take a look at how to look for the t table and how to use the R to calculate that. Okay, all right, and so let's stop at here for this video and talk to you in our next videos. Okay, bye.